Hi everyone, in the following series of videos, I will cover the graphs of the functions sine and cosine. Because these two functions have similar characteristics and the steps we take to graph them are also the same, I will be going back and forth between the two types of graphs. Alright, before I actually start with the graph of the sine function, which is unit 4, I want to mention something about the quadrantal angles. First, we used in Unit 3 a new definition for the trigonometric functions based on point on the terminal side. And I want to highlight a kind of special points related to the unit circle that's going to be useful for the graph of sine cosine. All right, so before I really start with the graph of sine, let me put somewhere on the side here. So quadrantal angles are angles that when you write them and sketch them in the standard position, the terminal side coincide with either the horizontal axis or the vertical axis. Looking at the angles in the standard position, we're going to be talking about quadrantal angles, which are angles that the terminal side coincide with either the horizontal axis or the vertical axis. So for example, 0 degrees, which is the same as 0 radians, is a quadrantal angle because the terminal side corresponded to the positive part of the x-axis. Now, another quadrantal angle is 90 degrees, and 90 degrees in radians is pi over 2, and the terminal side coincides with the positive part of the vertical axis. 180 degrees is also quadrantal, and that is the same as pi radiant. The terminal side coincides with the negative part of the horizontal axis. And 270 degrees, which is the same as 3 pi over 2, also is a quadrantal angle, right? The terminal side is here. Okay, so why am I talking about these guys? Because we're actually going to use quadrantal angles to actually graph the sine and cosine function. That is the case for all trigonometric functions when you graph them. Instead of focus on intermediary values, it's much easier if you focus on the quadrantal. Using quadrantal angles is the best way to graph them because according to our definitions before, for example, sine of any angle based on the point on the terminal side, right? So it's going to be y over r. And cosine is x over r. So given the quadrantal angles, for example, let's pick pi over 2 radians, which is 90 degrees. So I want to focus on particular kind of points. I want to focus on the points that are not just on the terminal side of the quadrantal angle, but they are coinciding with the unit circle. The unit circle is a circle that has radius 1. So if it has a radius 1, r equals 1, when intercept the vertical or horizontal axis, you're going to have particular points which are easier to identify. And r is the distance from 0, 0 to the point, right? So since the radius is 1, so this point right here, because the unit circle means that the coordinates of the point is 1, 0, right? Because it's a distance of 1, the radius, and because it's on the positive part of the horizontal axis, you have that point being 1, 0. So that is easier to identify. For example, for the other point right here in the north of the unit circle, you have 0, 1, right? The x coordinate has to be 0. That's why it's on the vertical axis. But again, because of the radius, you have then that the y coordinates will coincide with the 1 of the radius. These are the point right here on the west of the circle is going to be, because it now is in the negative part, it's going to be negative 1, 0. And the one on the south of the circle is 0, negative 1. So we're going to actually use these points because r equals 1 means that when you look at the definition for r equals 1, you just need to actually look at the y value for sine And for cosine, you have x over 1, right? Because r is 1. You have just to look at x. So basically, we're looking at both x and y. Okay, so for example, let's say I want to find the sine of 180 degrees. I need the point on the terminal side of 180 degrees. That is the point negative 1, 0. Negative 1, 0. Because it's negative 1, 0, I already know that the radius 1 is r, y over 1, which is y, and y is 0. So for 180 degrees, you have that sine is 0. Now let's do cosine of 360. It's also quadrantal. 360 degree correspond to this point right here because this is also 360 degrees, which is the same as 2 pi. Okay, so the terminal side is that. So the point on the terminal side of 360 is 1, 0. And again, for cosine, I need the x value because r is going to be 1 in this case. So basically, I just look at the x value because division by 1 doesn't change that. And the x value of the point I'm referring is this point right here. So the first coordinate is the cosine, which is 1. So cosine of 360 degrees is 1. So with the unit circle, these 4 points, it becomes kind of easier to graph, as you're going to see. Of course, in the introduction, we're going to see all the different values from the textbook, but we're really going to focus on these 4 points all the time